of the session 1. Please confirm that you can hear me. Okay, thank you. And I'm going to share the screen and we'll start the lecture. Okay. So you should be able to see the screen now. I'm switching the tab to the content from Big Data Analytics Google Classroom, right? All right. So it's been, 2 lectures already. We have described and some applications as well. But then we need to learn the definition of big data. If many times, we know a lot of stuff about certain technology or technological terms, but if someone asks us to define it in, one sentence, one word, likewise, we may not be able to do so. That's when official or at least theoretically you have to be aware of and be able to remember as well as reproduce the definitions. Okay, so somebody might have coined this definition of big data and it is accepted by the community. What you see on your screen, big data is high volume, high velocity and high variety information assets. So basically, it's talking about the V parameter or properties of big data, where the volume, the size is huge, the velocity, like the flow, the speed at which it's been produced, that's high velocity, and variety. We have already talked about structured data, semi-structured data, and unstructured data. So the varieties of data types, so all these three together. So big data is all these three, characterized assets. So of course there are assets. People say, remember I told you data is new oil and data is more important than software, etc. So that's when all this data been considered assets. Okay, and though you might have data, but if you may not be able to do anything on that, is of no use. So though we know crude oil is there buried 100 kilometers down the earth, but if you cannot take it out and if you cannot process it, and if you do not put it into the diesel or petrol engine, is of no use. So you got to understand that the big data is an asset, of course, but then it demands the cost-effective, innovative forms of processing, right? Why cost-effective? Because anything which is extremely uh, expensive is not going to help to the industry, right? So it has to be cost-effective. Moreover, it has to be innovative, otherwise it will not stay for longer in the market, right? So the assets, the data, it demands cost-effective and innovative forms of information processing. Here we will be actually talking about algorithms. So remember two important things: storage and processing, right? So, and why do we do this? That is the third part. So this definition is actually, considering the three aspects. One is the characteristic of the data, which is, V, multiple V's, like 3 plus V's. The second thing is the processing part, and that too, the cost effective as well as innovative. And lastly, why do we do this? I mean, if we are after something, of course, there has to be some fruits, right? So this information processing is for enhanced insight and decision making, right? So you do process, but you do for a reason, which is the enhanced insight and decision making for a better tomorrow. So I believe these three aspects of this big data definition is understood, right? So do remember this, and it is okay to put these words, here and there, but it is important that you cover these three aspects of big data in the definition if someone asks you what is big data. So one more time, big data is a high volume, high velocity, and high variety information assets that demand cost-effective and innovative forms of information processing for enhanced insight and decision making. So that's the definition. Do understand and do remember it. Fine. So that, of course, there is some supporting slide here which shows you the importance of big data, and do note down this website Gartner. You might hear it in many conferences, like, this data is by Gartner. Now, what is it? Go through it and find it out. Fine. So we'll move on to the next topic. So in the previous lecture, we described and learned uh, something called word count, starting from Linux WC command to finding words from huge amount of data with their frequencies like the count, and it demands some innovative and smart solutions. The reason being, the data is not just on a single computer. Even it is not just uh, megabytes or GB. It might be a lot hill of data there. So high volume basically. So we started talking about word count. Now you might have question how frequencies help. Just frequency. I mean, what a big deal, words and their frequency. But then if you see, there might be some applications. So have you heard about a term, word cloud? Word cloud. Okay. How many of you have heard this word, or you may give me some analogy to the term word cloud from your chat window? Okay. Are we connected, guys? Okay. Yeah. And I see little, less strength, 86 out of 140 or 450. So please spread the, words that there are interesting things in the lectures and labs. They have to be, present. Otherwise, they will miss all these things. Okay. So fine. So word cloud, maybe you might not have heard, but have you seen anything like this on the screen? Have you seen anything like this? The content might be different, but uh, such image have you seen? So yeah, few years recently maybe, or previous one. Uh, yeah, recent one maybe, right? Okay. So you guys have seen that image what I just shared, right? I mean, so what is it called? Such image, or at least tell me, where have you seen it? Those who have seen it, describe where have you seen it? Maybe in some cinema, on a big wall they might have pasted some painting like this, or maybe in some business hub, right? Wallpaper, basically. You might have seen wallpapers, right? And how is it important? I mean, what does it convey? Any idea what does it convey? It may be, words might be of any industry, like cinema, or stocks, or it might be some motivating words. The words might be any, but what is it conveying? So we have few answers here. So Jay says frequently used words. Okay. Then Rahil adds to it saying large size for more frequent words. Okay. And so Manan has seen some kind, same kind for picture of programming languages. Okay. So yeah, so good observation there. Yes, it is actually the bigger the word, that means it is of more importance. So larger the text size, more important. It indicates more important. Now, if you may want to, create such picture, how will you create it? I mean, what will be the programming logic behind doing the same thing? So first thing first, we have to create interest in the public from this kind of picture, right? It is we have heard that a picture is worth 1,000 times than just speaking or just a sentence, right? So uh, so basically, data is a part of data visualization. Okay, you guys will learn. We will learn reporting later on, but it's more like graphics, right? So you might tell people that this is important, that is important. I may tell to my daughter that this is important, that is important. Rather than that, I may create such picture and maybe use it as a wallpaper, which might convey the same thing, but in a better way, right? So whichever words are having more important, their font size will be larger compared to the less important words. So how will you create such image or diagram from the data sets available to you? Any idea what will be the algorithm? I mean, I already spoke a little bit about the same thing, but still, can you refine what I just mentioned? Okay, so Rahil says first arrange according to importance. Yes, but Rahil, how do you find importance? So Jay says count frequency of words. Correct. Yes, yes, yes. So yeah, so honestly, at least if you have your personal of interest, you might arrange as per the order of your importance. But then if you might really want to identify the importance from certain data sets, right? We have actually the human brain, or we human like have experienced this, right? Over the period of time, we know what is important. We've been learning since our childhood, so now we know what is important. So that is one way to order it, yes, of course. But the other way is, if you have data set, for example, movie names from various places in various feedbacks or various uh, so let's say which movie was hit and which movie was not super hit. Likewise, so or let's say you have data that this movie made a budget. I mean, had budget of so and so. What is it called? Three-digit club movie, or what was that? I forgot actually. 100,000 club movie. I mean, whatever it is. So if you have certain data based on that, basically, if you have, you may short it, okay, uh, and then top 10 you might get, or top 50 you might get, and out of those you might create such wallpaper is possible. I mean, is then you definitely have to do graphics work, but the data input, the source of this graphics work, is nothing but plain simple words and their frequencies. Okay, it's just plain simple words with their frequencies. So the point here is, simple words and their frequencies. What all things can we do? Then I have already put upon one of the application, which is the cloud, word cloud. So you might hear the same wallpaper with some other another name, but in some technological terms, it is called word cloud. Okay, so I believe you guys understand it now. Word cloud is the image what we have seen, and it is actually outcome from the data set, and that algorithm, first thing first, counts the frequency of words, then maybe order it short, in descending order, and the top list, maybe 10 or 20 or 50, based on the algorithm, however it chooses. The topmost will be bigger in size of font, and the remaining will be correspondingly lower values of font sizes. And such word cloud conveys the importance of those words. So this is nothing but one of the application of big data and analytics. Okay, believe me, it is one of the application of big data and analytics. And it is the logic is as simple as word count, right? The logic is as simple as word count. Any questions on uh, the word cloud technology or picture? I mean, the idea. Any question on word cloud? I'm certain you understood how it works, right? So many languages, even on web, many online services, they provide you such image automatically created. You have to provide the data set, and that website or that tool will create such image for you They might give you some choices also, like colors, background, etc., and they can create these things for you. Okay, I know at least the language R. You might have heard about it, right? For data science and analysis, like Python, there is something called R language. I'm sure you have heard about it and might have explored it. So R, this is one of the lab work. Let's see. Yeah, this is one of the lab work. Okay, maybe I would have provided you the data also, and maybe a script of R. Though you might try to install R on your system, and then might use this script. You might need to change a bit depending upon how you want to do it. But then, lastly, once you have the frequency, you have to provide the data set to the word cloud library, and it will generate such plot for you. Okay, so do this activity if that interests you, but that's also part of the lab work. Okay, going forward some point in time. The word cloud was one of the application, or is one of the application of big data and analytics, starting with word count frequencies, right? Okay, so I'll close those tabs. Okay, so bringing you this high levels aim, this list should grow, and you should also make your own high level aims list for yourself. Keep appending more and more aims for yourself, right? And keep achieving them. For example, we talked about RTAP. Remember OLPP, OLAP, and RTAP, real-time analytical processing. So it is actually used in fraud detection. Why you need to do real-time analytic? Because like credit card frauds, or banking frauds, or uh, stocks sales. I mean, fraud has to be detected as soon as possible, and that's when the real-time fraud detection named, right? So that's one of the aim you might want to work upon. Okay, then how do you detect live traffic? We already talked about it in the previous class, right? Then crowdsourcing we have talked about. We'll be actually talking about something called finding mutual friends. Okay, that application will talk, and such. So these are all few applications listed down here. But as I said, you all please prepare high level aims for yourself to achieve uh, using AI, big data analytics, and ML, like machine learning. Okay, fine. So this actually gives you some idea that even, let's say, when you use this Facebook, it suggests friends, right? Uh, it suggests, right? So how it might be doing it. So that's when there is one simple programming example which we have come upon, is called finding mutual friends. So there is assignment for you. I'll actually open up the tab to give you some detailed example, but that is going to be assignment starting this week uh, till we really solve it using some other technology later point in time. Okay, there are many more questions. I mean, we can learn about, like, how many new friends a Facebook user gets in a day. Okay, I mean, think of such things like, how do you identify the communities in a given network? Like, even for economical growth, maybe government might utilize, even for the campaigns, right? They might want to identify communities in a given network, so that they can help them in a better way. So finding communities in a given network, uh, you might have heard about this graph and their applications, right? So that has to do with graph based data analytics, right? How do you find all dead ends? Okay, so this is again one more application. Property prices and amenities. I mean, their connection relation with area wise, amenity wise, what will be the property prices, their prediction. There's so many things I try listing as and when it came to my focus. How to find rare events. So do learn this rare events. Okay, in history, in society, geographically. I mean, in every domain, how to detect rare events. Okay, so rare events have importance. Okay, if you may detect whatever has happened or happening or going to happen, that is gonna get you some fruits. How to carry out effective web search. So this has to do with the data analytics, which actually uh, helps user for effective web search as well as utilization, right? And we'll also talk about some e-commerce purposes where the customer oriented decisions, like what my customer are talking about my products and services, identify the probable defaulters in a bank loan or credit card. Defaulters means whoever might not be able to uh, pay back the loan or credit card in time. Okay, so then maybe credit scores. How do you decide credit scores of individual or firms, right? Then dimensionality reduction. In the previous lab, I mean, we talked about data cube there, where we talked about slicing and dicing, etc. Slicing was one of the example of dimensionality reduction. Okay, so a lot of high level aims are possible with big data and analytics, and I'm literally into touching up all this one or other way. And I welcome you all to help me grow this list. So you may email me if you have come across some more high level aims. I would actually add to this list. Of course, the courtesy will be made clearly here when I write it down, okay, with your name. Fine. So high level aims, that was one topic I thought I should be covering to bring all of you to focus. So there are students, again, as I said, 86 only. So make sure you wake your friends up and let them join the class, okay, and labs. Not only BDA, of course, all lectures and labs, right? Because whatever you'll hear from our experience, that's definitely going to help you in your career going forward, right? Okay, so with that, let's move on to the next topic. Any questions? So we have talked about two application. I mean, word cloud, and second one, like so many of here, right? Uh, okay, high level aims. Fine. Okay, so um, let me finish this. Okay, finding mutual friends assignment. Any idea how will you solve that? Finding mutual friends. I mean, or you need some time. I mean, I would like you guys to do it on your own, other than me telling the answer. Okay, so whoever solve is it first. I would definitely like to give a college. So Muhammad says DFS or BFS. Uh, fine. So he's thinking with respect to graph. He's thinking that the friends, for example, Facebook, or persons like connections in LinkedIn, they are represented as graph. So he's thinking to do DFS or BFS and kind of look into it. Um, so there can be, of course, a lot of various ways you can think of. It primarily depends on how the data is stored, or what is the input made available to you in which form, like data structure. Then you might have to take another route to solve. So Jay says finding neighbors of neighbors in the graph. Okay, so as I said, is open and primarily depends on how the data is available to you, in which form. Okay, the application which I have created here is actually, you have data available in terms of some pre-processed data is available to you in forms of lines in files like text files. Okay, so here you don't have graph data structure. I mean, you definitely can have it, and of course that's one way to go about. But this is another way where a line as input gives you the information that person A has friends B, D, and E. So this is very much like if you consider the graphs, these are, there is a connection from A to B, then D and E, something like that. Okay. And then, of course, because A is a friend of B, B will also be friend of A, right? So it's both ways. So mostly friendship graph, you cannot think of it being, directed. Uh, right? I mean, we don't think like one friend is of another, but the vice versa is not true. We assume that both are having the equal friendship level. Okay. Otherwise, you can always have levels associated and directions. If but for now, is bidirectional. I mean, is unidirectional. You may say. Okay. So let's say I'm giving you set of lines. Each line conveys the information that person one has how many friends. Okay. So friend names or friend identifiers basically. Okay. So now given this set of lines, okay, so you can imagine thousands or millions of such lines. I mean, that depends on how much big the community is. Okay. So if let's say Facebook, then it might be uh, worldwide people, right? No one is exempted. I mean, everyone is using. So whatever is like world population, at least half of them must be there here. So those many lines we are talking now. Of course, that's volume wise, big data. Now processing wise, how do you really do that? So one computer will not be able to achieve the job, we know, because supercomputer even will have limit of resources, right? So you will need to come up with some parallel or distributed storage as well as processing framework, and that's what is really used, right, by companies. Uh, so imagine you have this such input, and what output do you need? Imagine you need such output. At least you are required to just show friends between two people. That's one of the aim. This aim can be different also, but one of the aim is you have to show common friends or mutual friends between two people at a time. Okay, and you might not show those which are not having any common friends. You might not show these lines. It is just written for understanding sake. So how will you solve this problem? As I said, I'm not trying to discuss this right now. You can create your own way of input and your own way of output, but finding mutual friend is definitely one application of big data and analytics, and you guys can work on it. uh, we are going to work on the same via our own mechanism of programming. uh, we will talk about it, but keep this in mind. Okay, you will soon have to solve this problem, so keep this in mind. Finding mutual friends. So let me fine. So Vishal might have tried writing something. I'm not going to read that because I want solution from everyone. It's okay, Vishal. You might have touched upon the solution, but others I would temporarily try to avoid discussion on that. Okay, or let me just defer the discussion of that solution. I hope Vishal, you don't mind. Okay. So do copy these lines and email me. Maybe I will do that myself if you, okay. But then we'll talk about it later on, because I want all of you to, think while we talk about some other paradigms or, some other mechanisms. Okay, fine. So, uh, hmm. All right. So, what is this guy name? Vishal. Is that you, Vishal? Yeah, fine. So we'll talk about it. Okay. All right. Fine. So let's move on to another topic now, where we are gonna bring you Hadoop. Okay, so let's get started with Hadoop. Now, yep. So why I have to start, because you will have labs also, right? So somebody asked in the previous lab what all other things you have to install. So I think I described towards the end of the lab. You guys will need Java. You guys you'll of course databases of your choice, right? Then you will need Java. You will need to install Hadoop. Okay, if not on your own computer, you can choose to go use IBM, Oracle, and like clouds which provide you Linux nodes or terminals, and also big data as a service. So maybe in this class here, I did it with Oracle. Yeah. So you might try even this one, Oracle Big Data Lite Virtual Machine, if you're able to download and install. Uh, okay, Oracle Big Data Lite Virtual Machine. Okay, and OCI, that is Oracle Cloud Infrastructure. It also provides a service called Big Data Service. Okay, so try about it. Okay, there's one place on the cloud where we know we can do our labs, or you can practice Hadoop. There are other ways also. Okay, we'll talk about it as in when we touch. Okay, so let me take up this topic right now to start. What is Hadoop? Okay, and we'll say history of Hadoop. So I already mentioned, those research papers by Google from the year 2002, 4, and 6, right? So that's the beginning for a lot of cluster and distributed based storage as well as processing, and this is from Quora, right? There are a lot of input on the same site, right? So maybe this image is from other site, right? What you see from on the right. Of course, all the courtesy to the respective content creator. Uh, okay, so Apache Software Foundation. We guys are aware of the same, right? Apache Apache Software Foundation (ASF), right? It's a non-profit for the community, right? So then, there was something called Nutch, Nutch, and the guy named Doug Cutting and Mike Caffarella. So Nutch, know about Nutch, learn about Nutch, okay? Learn where was it created, what is it, etc. Then, the guy, this Doug Cutting, he's the, one of the pioneer person in development of Hadoop, but he actually started working on Nutch. He moved from one company to other company. You can, learn about the companies also, like he joined Yahoo, etc., right? And then 2008, I remember, in 2009 or 10, my company, uh, people attending conferences on Hadoop uh, in New York City. I remember that. Okay, that's when I was introduced to what is it called, Hadoop, but then specifically the distributed file system of Hadoop HDFS and all. Okay, so yep. So you see Hadoop. Okay, so now Hadoop has various releases by various tech giants as well as various communities. Okay, so Hadoop is, Hadoop will have Hadoop core, but then there is a lot of distributions, like Linux had a lot of distributions. Okay, so Cloudera is one more, which is having Hadoop based startup, and I mean Hortonworks is one more. Hortonworks. Okay, so learn about these different cloud providers. They use their own, or different such Hadoop uh, variations, like Cloudera. Hortonworks and all. Okay, but what we are gonna do is we are gonna take open source resources from Apache Foundation, right? So the website is Hadoop. Apache.org. Oops, I'm sorry. Uh, so this is where we will start. Okay, maybe 4 years. prior, maybe 2017, we started this, work here at DDU, and we have, as you know, we had, the cluster and all, right? So we understand it. Okay, we at least have skills to get this kind of clusters working in commodity hardwares at our labs. Okay, we have been, trying out our best to get you, such stuff. So you guys might go and download from here. That of course there'll be help. You know, so we literally refer this. Okay, nothing else. No other website. Nothing. This documentation, as you know, I'm very fond of utilizing official documentation, and which gives me power to get the job done most of the time. So this is the place where you will get started to have Hadoop experienced. Okay, fine. So go about it. I mean, you don't need to wait for the labs. You can start ahead, like how to install, etc. Fine. So two things. One will be the file system will be having one lab on these commands, which are primarily for file system, and then the processing, which is maybe, so HDFS is the file system, and then the map reduce, which is the the processing. Okay, so what we are going to talk today is something like mapper classes. Okay, mapper and reducer. Okay, so what is mapper, what is reducer? We'll touch this multiple times so that you understand it. Okay, but history of Hadoop and what is Hadoop and where should you seek help, I have already provided to you all. Okay, um, yeah, so start from Hadoop and get started. Okay, um, all right, so we have 18 minutes, I believe, and I will go introduce you the MapReduce framework. Okay. So what are we learning right now is called MapReduce framework. Ma'am will also talk about the same. Okay. So as I said multiple times, we'll touch upon this. Bear with me 1 minute. I actually I'm looking for something. Wait a minute. Uh, just a side note, I have updated this big data platform and courses. So remember lecture one where I actually mentioned to you that there are NPTEL or SWAYAM courses, right? So other than SWAYAM courses for the current year, there are many more courses what you might like to take up or go through or refer. Okay, from NPTEL, from SAS, from InfiniQ like Infosys, right? From IBM, DVC, data version control, Apache itself definitely, and others like Oracle and all. So take benefit of such platform and courses pertaining to big data. Okay. I'm looking for something if I can bring that up here. Okay. Oh yeah, why am I looking this? Yeah. So basically, we are going to talk about MapReduce right now. Okay. And the program what we will solve is the word count. Okay, the frequencies. Again, it has version one, and there is maybe later on, yeah, version two here. Okay. So there is little difference. We'll have to touch uh, once after another, one after another. So Okay, so let's refer this, right? Hadoop MapReduce is a software framework, okay, for writing applications which process vast amounts of data. Okay, so this is for big data, okay, basically. Uh, and this framework works in parallel on large clusters. And the cluster has been, thousands of nodes of commodity hardware. So at DDU, we at least demonstrated, 40 computers in one lab, and of course 14 another, and likewise. So if we might connect all the labs of DDU, we can also even reach to 400 or 500 computers. Okay, cluster of that size, and believe me, I can do that. Okay, of course it will, need a lot of permission and all, but the important thing is, yeah, I know how to do it. Okay, I definitely am aware of that. And I know scripting, Linux scripting. I mean, the Linux skills will definitely help you get there if you may want to, do such stuff. Okay, you may also have Windows based. I am not having that experience, so you might have to explore that on your own. Okay, but this is possible. This is, you know, possible. No big deal. Okay. Now, in cluster, actually, failure is a norm. We'll talk about it. The sentence I just made, failure is a norm. I mean, uh, norm means normal. Okay, so if someone says there is a failure in data center on certain nodes, it's not complete failure, I'm saying, but failure is a norm. That means people know that though we have done everything right, there will be some or other failure, but we have to devise algorithms to, overcome those failures. So that's important, and that's something about reliability, which we'll talk. Okay, so fault tolerance will be, the aim. Fault tolerance, failure will be there, but how effectively can you handle that? That is what, you will be after. Anyways, so MapReduce jobs, they definitely have a lot of inbuilt logic and algorithm to support this fault tolerance, even though you might have thousands of nodes parallelly, storing as well as processing the data. Fine. So what does it do? It usually splits the input data set into, chunks. Then it provides this input chunks to map task. So MAP map is one type of task. Okay, that's when the framework name map reduce. So map is one phase, another phase is reduce. There are a few more intermediate phases we'll talk about later. So map phase is getting these chunks to be processed in parallelly. So there will be, of course, many map tasks, right? Now, uh, the framework actually sorts the outputs of the maps. Okay, it has some mechanism to do sorting. Now, one of the sorting can be, the way we do hashing or bucketing, right? Bucket sort kind of stuff. It's possible that it might be internally using, kind of hashing or, bucket distribution. Okay, so it sorts the output of the map task. So I repeat, you might have number of lines which are the input. Okay, now there are, the number of lines given to the mapper task, and map task, they produces some outputs. So of course that's called output of maps. Now what is it exactly is, we will learn, is primarily going to be key and value pair. Okay, so know that Hadoop and certain, distributed computing, many technologies are utilizing this key value concept a lot. Okay, a lot, I'm saying. The reason being, it is very straightforward to do hashing or sorting or even, referring, counting. I mean, storage, so many more things. Key value pair is a key technology, very simple but powerful to achieve a lot of algorithmic solutions. Okay. So then that output will be given to reduce task, and again reduce task will do certain logic to prepare another set of output. Okay, so we will actually learn what map does and what reduce does with respect to the word count program. Okay, So typically both the input and the output of job are stored in file system. So know that we cannot store everything into main memory, because main memory always has a limit. So even the intermediate results will be stored into file system. Okay, so that's what distributed file system heavily relies on. The secondary file system as well, because of the volume of the data. Not everything can be stored into memory. So it's very much like paging of operating system. I believe you guys understand paging of operating system, like virtual memory and all, right? So here, I'm not just saying it is virtual memory, but you know that the output intermediate results are also many times stored on a file system. That means, persistent. The framework takes care of scheduling tasks, monitoring them, and re-executing the failed tasks. So as I said, failure is a norm. If there might be, any failed task, the framework will re-execute it. Okay, framework will re-execute it. All right. So, what are going to be input and output? I clearly mentioned the MapReduce framework exclusively operates on key value pairs. It views the input to the job as set of key value pair and produces another set of key value pair. Note that the type might vary, okay? The type might vary. For example, here this value might be induced as single value, while here it might be list of values as well, okay? So know that type might vary, or you can even customize, okay? The key and value classes have to be serializable by the framework, and hence need not implement the writable interface. So there is more, technicality is primarily written in Java. You can, understand what is serializable and all. So there is heavy usage of those things what you have learned already, right? So let's go about it. There is a program, right? It is using the Hadoop library, right? The class name of your own, there's a word count. Okay, so then there is a function called map, map, and there is a function called reduce. Okay, the only two function, map and reduce. What you write, that prototype is fixed. What you do within them is your own logic. For example, this word count program, this is what the logic it needs. Okay, so now understand this. There is of course a driver program, right, which will fix the input location for the data files, right? And then all the data files will be read one by one. So how it works, data files, the lines are given to mapper. Okay, that is the first phase. And what does mapper do? It actually, reads it token by token. So it will be actually a line given. Then from the line, it actually creates words, which are nothing but tokens. Okay, and it does what? It actually creates a key value pair as an output, which is nothing but the word as a key, and one is actually why is it not shown here? Oh yeah, it's one. One is nothing but count one. Okay, digit one. So what does map function do? It takes line by line input, tokenize the words, like separates the word, and for every word, the key is the word name, that the spelling of the word itself, and the value is one. Now don't confuse yourself with the term key. Okay, so normally when I say key, you might think like there'll be only one pair which will have key, let's say Ahmedabad, or key, let's say Naryad. Not necessarily. Key doesn't mean primary key here. Okay, so please make sure you understand this. Key here doesn't mean primary key. No, key here means only with respect to the key value terminology and the uses. Key is nothing but something to identify what the value belongs to. That's about it. So Ahmedabad might be there so many times as pair of key value pairs as a key. So you might have 100 key value pairs where the key might be Ahmedabad, and that's possible. That's literally okay. Here we are not talking about primary key where you think like there'll be only one single key value pair where key will be Ahmedabad. No, not necessarily. So that's not the purpose here. Okay, that's not the purpose like primary key. Later on, when there will be, it will be highlighted. I'll show it to you. But for now, understand this key value pair means set of key value pairs where keys can be repeated also. I mean individually that key value pair has the importance. Okay, fine. So simply all the lines, words from all the lines, this map function just creates key and value pairs, nothing else. So there are so many key value pair. For example, there are 500,000 words, then there are 500,000 key value pairs. And what are they? They are just the word itself with the value ONE1. That's about it. Okay. Now, what do you think? How this might help? I mean, is it insane to do this? I mean, 500,000 words, not necessarily unique, of course, 500,000 words, and we are just creating, 500,000 key value pairs. I mean, is it insane? I mean, what is the benefit of doing this? Any guess? Any guess? What do you think? Creating 500,000 key value pairs, just having the word as key and value as digit 1. I mean, that's about it. Now, how that might help? I mean, how literally that might help? The point here is, or at least you think, okay, what is the aim? You want to do word count, and the data is scattered across, many nodes in the distributed file system, and they're line by line. You just have to read those, text, identify the word, and count frequencies. But know that the local count has to be merged with global count, because you cannot say, Ahmedabad happened 50 times on this one computer in this one file. You have to say Ahmedabad happened, maybe 700 times from the global data set. So you might do local work, but you also have to then, maybe do some sum up kind of stuff. And still, I mean, why the step 1, which is nothing but, saying word and the number 1, word and the number 1, word and number 1. I mean, how that might help? What might you do in the second step? Yeah, so Vishal is saying we can sort later, collect all pairs with the same key and add up. That's exactly what the framework is doing, Vishal, for you. Very good, Vishal. See, I wanted you guys to think, okay, the reason being, whatever is there, and know that we are not learning Hadoop, we are learning logic, we are learning the, applications, we are learning algorithms so that we can apply these things on some other places also in future, right? So that's when you have to keep thinking. Yes. So what does MapReduce framework do? Map just creates key value pairs. Of course, logic can be of your choice. At least for word count, the logic is nothing but just generating word with one value. Now, the framework actually behind the scene, before it passes this key value pairs to reducer, what does it do? It actually, there are more phases which we will learn. There are phases called combiner. There are phases called partitioners and all. We'll learn about them. There are phases called shuffle. So there is shuffle and short, combiner, partitioner. There are more phases. Ma'am and myself will keep repeating and touching this as and when, various places we need them. So next thing, what will happen, the framework sorts and shuffles, and imagine it creates, various buckets, unique, one bucket for one word uniquely. So one bucket for Ahmedabad, one bucket for Nadiad, one bucket for any other words. And in that bucket, it is putting all those pairs which belong to Ahmedabad. Then in Nadiad bucket, it is putting all those pairs which belong to Nadiad. So imagine you have, buckets for, unique words with all those pairs kept inside those buckets. Now, these buckets will be one by one given to, or you can say parallelly given to different reducer, which will then do what? Any idea what might be the logic in reducer? Imagine reduce function gets one bucket, and all it needs to do is add the value. What exactly it needs to add? It needs to count how many pairs are there, right? It needs to just count how many pairs are there, or it can, add the value 1 plus 1 plus 1 plus 1 from each pairs, which is same exact way what you do, like count the number of pairs. You do not want to count the pairs, but literally you will actually do 1 plus 1 plus 1 plus 1 for every pairs. Okay, so the framework gives you set of pairs, and that's what I told you. What is the input to reduce function? You see that it is key, okay, and values, remember? So this key and values, actually it gives you all those 1 comma 1 comma 1 comma 1 number of times for the particular word. So for a given bucket, it will say Ahmedabad, and it will give you 1 comma 1 comma 1 comma 1, those values. Let's say it happens 700 times. All you need to do is, add up that 1 comma 1 comma 1, and of course you will come up with the answer, let's say 700, which you then again write it into the output, like key Ahmedabad result 700. Such a way, this function will be run for every individual key for the set of values, and that will be returned to, files, and synchronization and all those OS concepts are definitely taken care. Okay, that what was that, semaphore and all, right? So those all things are definitely behind the scene working there. Otherwise, there will be inconsistency, right? So this is how the word count program works to start with. Okay, the map and the reduce. Finally, we'll have the word and its count, and we know what are the advantages of word count. The one application of word count we have already found out, which is the cloud graphics. Remember word cloud graphics, right? So fine, I think I got to stop here. 2 minutes already. I have done more. Fine, we'll connect again in the next class.